Hello students. Now let us continue with our discussion on magnetism. In today's discussion we'll be discussing about what are other properties of magnet and what are poles of a magnet. Now you have seen that when the iron fillings are kept and you place a magnet near it, then the extreme ends of the magnet, they attract maximum amount of iron dust or iron filling. Okay, the reason is that there is certain special area inside the magnet which has got greatest magnetic force or magnetic properties, and these areas, they are known as magnetic poles. They are generally at the extreme ends of the magnet. Okay, one end is known as North Pole and the other is known as South Pole. The naming of North Pole and South Pole depends upon one special property, that is the directional property. Now if you suspend a magnet freely from a vertical plane and if it is free to rotate in horizontal plane, okay, then the magnet orients itself in one particular direction. The end which orients itself or points towards or seeks north of Earth, that is known as North Pole of the magnet. So this is North Pole because it is seeking north. And the other end obviously is the South Pole because the opposite end will be the geometric south. Okay. Now there is one very interesting property about a magnet, is that if you take a very large magnet and you try to break it into smaller magnets, so in that case the broken magnets or the two new pieces, they are also magnet and both has got north and south pole. Now let us say we take the case of this magnet which is broken down in two pieces along its length. That means you break it here in two pieces. Now the two new pieces, they will be magnets, but each will have, let's say this is north, this is south, because originally they were north south. So again the two pieces has north and south, but the strength of magnetism or the magnetic properties will be slightly lesser. Okay, but the important point here to learn or to understand here is that you have broken down a magnet into two pieces, still you have two magnets. Okay, you do not get north pole and south pole separately. Okay, this is the beauty of, or this is how nature works. Every time you find a magnet, that magnet will have north and south pole together. Okay, it does not matter whether the size is big or small. Okay, now let us say we break down the two pieces, break down the bigger magnet into two pieces, okay, along its length like this. The two pieces again will have north and south, both will be magnet. Okay, now if the magnet is broken down into large number of smaller pieces, then each piece will be a magnet and each piece will have its own north and south pole. This is the beauty of magnet. Every time you say that you have a magnet in hand, that magnet will always have north and south pole together. You can never find a magnet having only north pole or only having south pole. Okay, always north and south pole, they exist together. Now there are certain rules about the magnet, and they are: first is that like poles repel each other. Like poles means similar poles. That means if south pole of a magnet is placed against a south pole of another magnet, you will find some kind of repulsion. Now there is no contact. It is a non-contact type of force. Okay, it's a non-contact type of magnetic force, and this is repulsion when south-south are tried to brought in contact with each other. If you try to bring them closer, they will be repelled harder. Similarly, even if north-north pole are brought together, they will repel each other. And this force of repulsion is non-contact type force. The other rule about magnet is that unlike poles or poles having different polarity, they attract each other. So here you have, let us say, north, so this is south. So if north south they are brought closer, they will be attracted, and lesser the distance, more will be the force. Okay, again this force of attraction is non-contact type. Okay, it's a non-contact type of force. Okay, now it does not matter whether you have, let's say you have magnet 1 here. So if even if you turn around the polarity of magnet, same magnet, but you have reversed the polarity for both. This is magnet 2. So when magnet 1 and magnet 2 with north and south pole placed in this fashion, they were getting attracted. Now if you reverse the polarity, you bring south here and north of magnet 2 here, they will be again attracted only. Okay, so it does not matter how you orient themselves. The only thing is that if unlike poles are there of two different magnets, they will be attracted, and this force of attraction is non-contact type of force. Now why this force of attraction and repulsion is there? We will not discuss about this much in detail in your grade 6 physics, but I will give you a brief idea. And the reason behind this non-contact type of force, whether it is attraction or repulsion, the force is non-contact type. The reason is magnetic field. Okay, the magnetic field is a special property of any magnet in which certain invisible lines of force, they exist in space. Now here I have shown certain arrows. You can see that there is an arrow, okay, which is directed, it is leaving from this pole. Let us say this pole is north and this pole is south. So you have magnetic field lines which are starting from north and they are going towards south. Okay, and if any other magnet which has its own magnetic field will come closer to this magnet, then the magnetic field lines, they interact with each other. Okay, they interfere with each other. Okay, now when this interaction of magnetic field lines takes place between the two magnets, they exert force. Okay, so the magnetic field lines which are invisible, this you should keep in mind that these magnetic field lines, they are invisible, and when these invisible magnetic field lines they interact with the magnetic field lines of other magnet, they exert force on each other. This force is mutual. Okay, if magnet 1 is acting or is responsible for some attractive or repulsive force, then magnet 2 will also exert same amount of force on magnet 1. That is the meaning of mutual. Okay, if M1 is repelling M2, then M2 is repelling M1 with the same amount of force. Okay, this is the meaning of mutual. Now let us do certain exercises so that the concept about poles become clear. The first exercise is, what happens to the suspended magnet when the south pole of the other magnet is brought near its north pole? Okay, so we have a suspended magnet. Okay, let us say it is suspended from the ceiling of a room, and you have north pole and south pole of this magnet. Okay, what happens to the suspended magnet when the south pole of the other magnet is brought near to its north pole? Now you bring in one more magnet, and the south pole of this another magnet is brought closer to the north pole of this. So you know that unlike poles, they attract each other. So there will be force of attraction, and because of this attraction, the new position of this magnet will be here. It will be slightly tilted. It will try to reach out to the other magnet. Okay, so there will be a shift. Earlier it was here, now it has shifted here because of attraction towards the other magnet. Okay, now let us do the second exercise. What happens to the suspended magnet when the north pole of the other magnet is brought near to its north pole? Now this is the same problem, but the only thing is that we have reversed the polarity. Okay, now this is the magnet, north pole, south pole. You bring another magnet with north pole and south pole like this, and if you bring it closer, this will experience force of repulsion, and because of this repulsion, it will be now like this. Okay, this is will be north, this is south. Because of repulsion, it has shifted. Okay, so there will be repulsion because like poles repel each other. Now let us discuss about Earth's magnetism. We all know that when a magnet is suspended vertically, which is free to rotate in horizontal plane, then the magnet orients itself in one particular direction, which is north-south. Okay, now why this thing happens in the first place is something which we should think on. Now, based on the discussion that we just had, if north and north pole they are brought together, brought closer, they will be repelled, and south pole will be repelled. Now what happens in the case of the magnet which suspends vertically is that it tries to orient itself along the magnetic field line of Earth. That means Earth is a huge magnet. Okay, now we will discuss this in much detail. Let's go through this line. If a bar magnet with ends marked north and south is freely suspended, then the north end of the magnet would seek geographic north pole. Okay, now the north pole of the magnet, let us say this is north pole of the magnet. So when suspended, it will orient itself in the geographic north direction. Now we also know that north and south poles, they get attracted towards each other. That means the geographic north is actually the magnetic south pole. Okay. Now to discuss this point in detail, we should also look at one more interesting thing, is that how a magnetic compass works. Now, or why a magnetic compass works. Okay, the reason is that Earth itself is acting like a giant magnet, and the magnetic compass works because there is magnetic field of Earth. The Earth has got two magnetic poles which lie near the north and south pole. Now remember one thing, they are near the geometric north and south pole. They are not exactly at the north and south pole. It is the magnetic field of Earth which causes the needle of the compass. The needle of the compass is magnetized, okay, which is made of steel or iron. Now this is the reason, the magnetic field of Earth is the reason behind the rotation of this iron needle, which swings in the north-south direction only. Generally, this red painted portion always points towards the north of the south of the Earth. Now let us look at this picture. You have Earth here, okay, and Earth can be assumed to have a very large bar magnet embedded at its center. Now the south pole is actually at the geographic north pole. The south pole, or the magnetic south pole of the bar magnet, this bar magnet is a assumed magnet. Actually there is no magnet inside. Okay, it is only assumed that magnet is inside. Now if that magnet is there, then the south pole of that magnet will be at the geographic north pole. Please keep this point in mind. And the geographic south pole has magnetic north pole. Another thing is that this south and north pole of the assumed bar magnet of Earth, they are not exactly on the south pole or the north pole. They are slightly inside. Okay. Now let us look at the points. Since Earth is a huge magnet in itself, the north pole is attracted by the south magnetic pole of the Earth. And Earth's geographical poles and magnetic poles, they are not the same. Okay. Third point is magnetic pole is found deep inside the northern hemisphere of the Earth. Okay, and it has got south type magnetic pole. Okay, this point we have just discussed. The south pole, which is magnetic south pole, is found deep inside the northern hemisphere. It is inside, okay, inside the hemisphere. And the last point is Earth's magnetic North Pole is geographic South Pole. Okay? Please remember this point. It's a very important point about Earth's magnetism.